Right, hello and welcome to the Factor Theorem, which sounds like a game show, but rubbish. We are going to do some factorising of polynomials, but let's do a little background first. The highest power in a quadratic equation or expression is 2, so x squared is the highest. Then cubic expressions go up to 3, so we'll have x cubed and no higher. Quartics will go up to 4, so x to the power of 4. Quintics will be x to the power of 5, and so on. There's names for lots, I'm sure. They are all known as polynomials. So, for example, this is a polynomial. 4x to the power of 5 plus 3x to the power of 4, etc. Right? It's a polynomial. Different powers of x. Doesn't have to have all of them. You can see this one doesn't have x cubed. But even just one of them makes it a polynomial. And the degree of a polynomial is its highest power. So this is of degree 5. What's the degree of this polynomial? It's degree 5 because it's got x to the power of 5 in it, right? I don't generally call them quartics or quintics, but it's there if you want to use it. Polynomials do not have negative or non-integer values. So they have to be whole numbers and they have to be positive, is basically it. You don't see one with fractions or negatives, okay? Which makes it a bit easier. There's a formula to solve the quadratic function, which you're probably aware of, which is this fella, minus b plus or minus the square root of b squared minus 4ac all over 2a. There is actually one for the cubic one as well, which is horrifically big and awful. And apparently there's one for a quartic one, which I've never seen, which is very, very complicated. It's just really unwieldy. It's the sort of thing that a person's not really going to use. You might stick it in a computer, maybe. All right. But for further maths, we only need to solve higher polynomials that can be reduced to linear or quadratic factors. Basically, we can take these higher polynomials, like degree 5, and we'll be able to split them into factors which are either linear, so just x and a number, or they're going to be quadratic, so they just go up to x squared. And we already know how to solve those by factorising them. Okay? So what do we already know? We can factorise some quadratic expressions, like I just said. So this one here, x squared plus 3x minus 10. Obviously, we would be looking for factor pairs for negative 10 that add up to negative 3. So in this case, x minus 5 and x plus 2. Multiply to make minus 10, add to make minus 3 or negative 3 there. And that means we could solve it. We know the values of x because we try and make these brackets equal 0. So x is positive 5 and x is negative 2. That stuff has been covered loads before, so I'm not going to go over that again. Thus, the factors, the things that divide my original expression over here... I need a pen. Let's get a pen. There we go. So the things that divide my original expression, not that bit, let's just talk about this bit, are x minus 5 and x plus 2, because look, you can multiply them together to get it. So they are factors. Okay? Remember, factors divide things. Right? What happens when we substitute the roots into the equation? Now, the roots are just another name for the solutions here. X is 5 and x equals negative 2. You probably already know what happens when we do this. But let's say we substitute 5 into my original equation or expression, and it equals 2, For 25, take away 15, take away 10 is 0. Did I say 2? I meant 0. And then when we substitute negative 2 in there, negative 2 squared is 4. This turns into positive 6 here, so that's 4 plus 6 is 10. Take away 10 is 0. This leads us to what we call the factor theorem, all right? Which is a very useful result. If x minus a is a factor of a polynomial, so for example here, x minus 5 is a factor of this polynomial, then f of x, then f of that number there, a, will equal 0. Basically, if x minus 5 is a factor, putting 5, positive 5, so the opposite sign, into our equation makes it equal 0. Okay, now the reverse of that is the important bit. If we have a function, so our function here, x squared minus 3x minus 10, if I put a number in it, a value into it, just substitute it in, and it equals 0, that means that x minus that number is going to be a factor. Right, this is important because if I just, if I get my function and if I chuck a number into it and it equals 0, that means that a factor of that particular expression, quadratic expression, whatever it is, a factor of it will be x minus 3. So we can essentially, if we wanted to, keep chucking numbers into a function until it equals 0, and then we know factors. We use those as factors of it. Right. It probably makes a bit more sense when we do it. For anyone that's thinking that makes no sense at all. If it doesn't, just rewatch that, because I said all the right words, and most of them in the right order. Right, so given here, so here is our function, x cubed plus 2x squared minus x minus 2. I've just, functions, we're just giving it a name. So f of x is that. Find f of 1, f of minus 1, f of 2, and f of negative 2. All right, so we're going to put those numbers into our expression and just see what values we get. Hence, that means once you've done that, using your results, factorize my polynomial here. So f of 1, first of all, we're swapping x for 1, so it's 1 cubed plus 2 lots of 1 squared minus 1 minus 2. Well, 1 cubed is 1. 1 squared is 1 as well. So that's 1 plus 2, which is 3. Take away 1 is 2. Take away 2 is 0. This means that a factor of my polynomial at the top there will be x minus 1. Because when we put 1 into it, it equals 0, using the factor theorem. Let's try the next number they suggested. So they suggested minus 1, so we'll put that into it. So minus 1 cubed plus 2 lots of minus 1 squared minus 1 minus 2. Well, this will be minus 1 cubed is negative 1. Minus 1 squared is positive 1, and when I times that by 2, I get 2. Minus 1 is plus 1, and then we've got negative 2 on the end. So that's minus 1 plus 2 is positive 1. If I add another 1, I get 2. Take away 2. This means this equals 0. Great. So we got another factor, x. And this is plus 1 because it was negative 1 we put into it, which means it's positive 1, or x plus 1, is the factor. So we've got 2 factors already. Need another one. Right, 2. So I'm going to substitute 2 into it. So 2 cubed plus 2 lots of 2 squared minus 2. Minus 2 on the end there. Now, I've already worked this out, and I believe it's going to be 12, because it's 8 plus 8 is 16, take away 2, yeah, 12. That means 2 is not a factor, or rather x minus 2 is not a factor. So let's try the other one they suggest, negative 2. So that's negative 2 squared, cubed, which is negative 8, plus 2 lots of negative 2 squared, which is positive 8. So we've got negative 8 and positive 8, so we're up to 0 so far. And then take away negative 2, which means plus 2, so we're at 2. Take away 2. Basically, when you work that out, it equals 0. If you don't believe me, do it in a calculator. It's 0. That means we've got another factor, which is x plus 2, because obviously it's the opposite sign to the number that you actually put into it. So hence factorize it. All 3 of these are factors. In fact, I know they're going to be the only factors because it's x cubed. So by the time I've expanded these 3 brackets, I'm already going to have x cubed, so there can't be any other factors. Another quick check is to take the constant terms on the end and multiply them, and it should equal your constant term, because that can't come from anywhere else. It must just be from those 3 numbers. 2 times 1 is 2, times it by negative 1 is negative 2, right? So I have got my factors. There we go. I've factorized it. There it is. We just chucked some numbers into it until we found some that equals 0, until we got all of our factors. All right? Easy peasy. The factor theorem is really useful. Throw numbers at the wall until something sticks. There's your factors. Maybe a bit more educated than that, but it's essentially the same thing. Right, another polynomial. So it's of degree 3 again, because it's x cubed. What's the question this time? Show that x plus 1 is a factor of f of x. That's easy. Suggest other values to do. Okay, we might need to think about that a little bit. I don't think, is there another bit to that? Oh, and then solve it, obviously. Right, I'm going to show that it's a factor by putting in -1 and seeing that it equals 0. So -1 cubed plus 3 lots of -1 squared minus -1 minus 3. That equals -1 times -1 times -1 is -1. -1 squared is +1, so 3 lots of that is 3. Taking away -1 turns into +1. And then we have -3 on the end. Basically, -1 plus 3 is 2. Plus another one is 3. Take away 3 is 0. So, by the factor theorem, it is a factor. Suggest other ones to try. Okay, well, this is the thing. So I've got 3 brackets here that will be factors, because it's x cubed, right? So I'm going to have these 3 factors. We already know 1. I don't know what the other one's going to be. And I don't know what the third one's going to be. But I do know that if I take those 3 numbers and times them together, those 3 constant terms, we get -3. Now, one of them's already 1, so I need pairs of numbers that multiply together to make -3. So 1 times -3, both of those could be my factors, or it could be -1 times 3. So we've got 4 numbers to try. Excuse me. Once I found one of them, I should have the other. Let's try putting in... Oh, in fact, we already know we've got -1 already, haven't we? So I already know that. So let's try 3. Let's try +3 and see what happens. So we'll have 3 cubed, which is 27, plus 3 lots of 3 squared, which is also 27. So we've got 54. This does not look promising. Oh, and then we're taking away 3, so that's 54. Take away 3, 51. And then take away 3 on the end is, well, that's not very good, is it? That's 48, right? So that clearly is not a factor. Let's stick 1 into it and see what we get then. So +1 this time. Excuse me. So 1, oops, that should be a bracket. 1 cubed is 1, plus 3 lots of 1 squared. Well, 1 squared is 1, so that's 3. So I've got 1 plus 3. I'm then going to take away my 1. So 1 plus 3 is 4. Take away the 1 is 3. Take away another 3 is 0. So I do have another factor here, which is going to be x minus 1, which means, if we're totally right, -3 should be our other one. Should be our other factor. -3 is cubed is -27, plus 3 lots of -3 squared. Well, -3 squared is +9. Times that by 3, we get +27. So these have cancelled out. -27 and +27. We then take away -3, which is +3. Take away the 3 at the end, we're left with 0. So my 3 factors are x. And remember, we've got to change the signs. So it's x plus 1 for that first one. It's then going to be x take away 1. And then it's going to be x plus 3. Because remember, it was -3 we put in. So it's +3 in that bracket there. And we need to solve f of x for when x equals 0. This will be x will be equal to -1, x will be equal to +1, and x will be equal to -3. Just like you do with your quadratics, that is how you get your answer. Okay, your answers, you're trying to make the brackets equal 0. Yeah? I hope that made some sense. There's lots of me talking. There's plenty more of that to come for people that fans of me talking. Lots of stuff to come up. Oh, now this is much more fun. All right, this is a whole kind of related thing, but a different process, and it looks horrible to start with, but by the time you've mastered it, it's lots of repeating patterns. Once you've mastered it, you feel quite cool because it feels like real proper maths, right? We are going to take this expression and divide it by x plus 1, which doesn't really need to be in the brackets here, but I've already typed it up. I'm not going to restart it. Here's what you do. Listen carefully, try and follow along. And I'm going to sort of try and colour code this a little bit so you can see where different things have come from. Right, we're going to take the x that we've got here and we're going to divide x cubed by it. Now, x cubed divided by x is x squared. I'm only dividing by the x. And I'm just going to put that x squared over here, right, over on the side. I then am going to times it by the thing we're dividing by, this x plus 1, right? This is all going to repeat lots in a minute. Right, let's go back to the black one there. X squared, we just expand this bracket to get x cubed plus x squared. All right, that's the thing I'm then going to put underneath here. And you'll notice that the powers match, which is good, that they're supposed to match. That's the whole point. And we take one away from the other and see what's left. It's a lot like long division. Now, x cubed take away x cubed is nothing. 3x squared take away x squared is 2x squared. All right, so that's the next thing we're going to work with. We then bring down the next part, which is minus x. And we do the same thing again, right? And go back to my red here. So we're going to take 2x squared, and I'm going to divide it by this x over here. 2x squared divided by x leaves 2x. Yeah? Which I'm going to put over here. I'm then going to go back to my original little expression that we're dividing by, which is the x plus 1. And we're going to expand that little bracket to see what we get. 2x times x is 2x squared plus 2x. Okay, we're then going to put that underneath the bit we're working on, 2x squared plus 2x, and we're going to take it away. 2x squared take away 2x squared is nothing. Now be careful with your negatives here. We've got negative x take away 2x. Well, that's negative 3x. And then bring down the next bit, which is negative 3. And we do it again. It's the same repeating pattern again. You take the bit you're working on, so this time it's now negative 3x, and divide it by this x over here. Negative 3x divided by x is negative 3. So I'm going to put that over on the side. I'm going to rewrite my original expression that we're dividing by, which is x plus 1. Minus 3 times the x is negative 3x. I've got to tell you, everyone, I don't know why, but my wife is sat over on the side on her phone, laughing away, and I'm not sure why, whether it's at me or whether it's something on the phone. But I really want to know. Anyway, negative 3x, and then take away 3. Notice on this last one, that when you take this one away, you are left with nothing, because negative 3x take away negative 3x is nothing. Negative 3 take away negative 3 is also nothing. That means there's no remainder. So that is what we get when you divide it by that. All right, now I don't know if there... Was there another part to this question? Oh, this is annoying. I bet there is. No, there isn't. Okay, let's go back on that. What this leads me to a result, which means my original expression here, the x cubed expression, can be factorised into x plus 1. There's a linear factor and a quadratic factor, which is x squared plus 2x minus 3. And if I can factorise this quadratic expression, which I'm just looking at thinking, can I? Yes, I can. I could actually factorise it even further. So this expression here factorises into x, it's going to be negative 1, isn't it? And x plus 3. I think I'm not going mad there. If we multiply those together, we get minus 3. If I add them plus 2. Yeah, okay. And I could even solve it. If it asked me to solve it then, I'd say the values are x equals negative 1 from my first factor, x equals positive 1 from my second factor, and then x equals negative 3 from my third factor over there. Yeah? Right, this process, I know it looks horrific the first time you do it, but it's a real pattern. It just does the same thing again and again, just like it's like an algorithm. You just run your algorithm through repeatedly until you sort of run out of stuff, and it's finished. Or you get it wrong and redo it and cry. What's the next one? Oh, okay. So this is the same kind of question. Given that x plus 2 is a factor, so we know it divides it, work out a quadratic factor. What they mean is divide it by x plus 2 and see what the quadratic thing is that's left. Okay, so let's set up my bus stop again. And let's start off, let's do the same thing again with the colour coding. I think that's good. X cubed divided by this x leaves x squared. Now I'm going to put that over on the side. I'm then going to change to the blue and write my original factor next to it, so x plus 2, and then we expand that bracket to see what we get. X squared times x is x cubed, and then 2x squared is what was left with. So bring that over here. X cubed plus 2x squared. Now I've kind of made a bit of a mistake here because you should leave space for your polynomials, really. And I'm sort of thinking I might rewrite this because it looks messy. You should leave space for each one. So for the cubed, for the squared, and for the... I haven't left it for this one, so what I'm going to do, I'm going to shift that along there and just leave a gap, right? So I've scribbled out that, which is really neat, right? And we've got minus 5x minus 2. So I've made a gap for my x squared one. Right, after that little tragedy, we then take it away. So x cubed, take away x cubed is nothing. And then I've got 0 here, because there's nothing in the x squared bit. So, and we're going to take away that. So we're left with minus 2x squared. And then bring down the next level, which is the minus 5x. And then we start again. Run through the algorithm again. So minus 2x squared divided by x is minus 2x. I'm going to put that over here, minus 2x. Okay, let's change to the blue. Put in my factor that I'm dividing by, so x plus 2. And minus 2x times x is minus 2x squared. Minus 2x times the 2 is minus 4x. Let's try and write that a bit neater. Move this over here. So 2x squared minus the 4x, okay? And then take those away. Careful with your negatives. Minus 2x squared, take away negative 2x squared, leaves nothing. Minus 5x minus minus 4, so that turns into plus 4, leaves just one negative x there. So minus 1x, or minus x as I've put, because I like to keep it neat. And bring down the negative 2. And we do the whole algorithm again. Minus x divided by x leaves a minus 1. Right? Excuse me. So over here, I've got minus 1. And let's go to the blue. I've got x plus 2 equals, well, this will be, change back to the my original black. Minus 1 times x is minus x, like I'd expect. Minus 1 times positive 2 is minus 2. Write that in here. Yay, it's exactly what we want, because when we subtract those, we are left with nothing. So there is my quadratic factor, because I knew the other one divided it, so I used that fact to then write it out. So x plus 2, and then x squared minus 2x minus 1 is my quadratic factor. And if I could factorise that. I can't factorise that, so if I was going to solve it, I'd probably have to use the either sort of complete the square, maybe. No, actually I'm not going to complete the square, am I? That's rubbish. Ignore me. No, don't ignore me, because I'm your teacher. And what I would do is use the formula. And yeah, what's the next question? Moving on. Is there more? I've got a little thing up here that I've put up as well, which is useful. If f of b over a equals 0, then ax minus b is a factor of it. This comes from you probably recognise this kind of thing. This is just writing it explicitly. If you've got a factor written like in this form, make it equal 0 and solve it. And if you're not sure about that, then you're sure. Of course you are. You're awesome. Okay. Show that x plus 1 and 3x minus 2 are factors of this. Is there anything else to the question? Oh, hence solve it. Ooh, okay. That could be fun. Let's... is there another bit? Yeah, so we're going to put in f to the minus 1 of this. God, this has got order 4, hasn't it? So, blimey, it's going to take ages. So, minus 1 to the power of 4. I've then got plus 4 lots of minus 1 cubed minus 16x, oh, not x, sorry, minus 1 squared. I might resort to my calculator for this one if I'm totally honest, just to save a bit of time. Plus 10. Okay, so I've got to show, but basically, hopefully, that will equal 0. He says, desperately looking at his notes that he did earlier. No, now the cat's come along. The cat is joining in. This is not good. Cat, move your paws because I can't see my notes. You are so annoying. What are you doing? Go away. Yes, there you go. Right, now you're annoying me. Right, yes. So that equals 0 after all that. Yeah, it does. Put it in a calculator. Trust me. Don't have a cat. They're annoying. Then, I also need to show that the other one is a factor as well. So the number touching x goes underneath, which is 3, and the number on top is the 2. And of course, this time it's positive. I bet I've already written this, haven't I, somewhere? Yeah, there we go. Oh, I'm going to have to erase that now. There we go. And then we're going to substitute that into it as well. And I will write this out just so we've seen it. So 3 lots of 2/3 to the power of 4 plus 4 lots of 2/3 to the power of 3. Take away 16 lots of 2/3 to the power of 2. Take away 7 lots of 2/3. And then obviously plus the 10 on the end. And when you do all of that, obviously, if this was a non-calculator, you would have to do all of that work, you know. So this would be like 16 over 64 or whatever it is, and so on. And you'd have to work it out. As it is, if I put it in a calculator, it equals 0. Therefore, they are factors of it. Right, here's the cunning bit. I now need to be able to see what's sort of left over from my expression here. I'm just checking. There's no more to this question, is there? Ah, yes, there is. Okay. I've just wanted to make sure I've got space. Now, if I take those two factors and I multiply them together, I'm going to get a quadratic expression. All right? X times the 3x is 3x squared. And then we get negative 2x. We'll have it's plus 3x and minus 2. So 3x squared plus x take away 2. Okay, so there's my quadratic expression there. And what I'm going to do this time is divide by that quadratic expression. But it is basically the same thing. All right? Excuse me. Right, so it just takes a little bit more thinking about, but I promise it's the same. Let's go for the same thing, the red. This is I generally haven't seen them this tricky, all right? So this is really pushing the envelope here. Right, we're going to do 3x to the power of 4 divided by 3x squared. Well, when you do that, if you imagine it's sat underneath it, the thing that's left is just x squared, x to the power of 2. So I'm going to put that over here, x to the power of 2. And then we're going to write our expression we've got, which is 3x squared plus x minus 2. And we're going to expand that. It's the same process. All right, so that will be 3x to the power of 4 plus, what is that? That's going to be x cubed minus 2 lots of x squared. Right, so we're going to write those in here. 3x to the power of 4 plus 2 x cubed. Keep everything lined up. It's super important. Take away 2x squared. And then we're going to take it away. That will leave nothing. 4x cubed. Take away 2x cubed. Leaves 2x cubed. Negative 16 lots of x squared. Take away negative, so that's going to add. Leaves us with negative 14 x squared. And then we do the same thing again. Again, we'll do 2x cubed divided by 3x squared. Okay, now when I do that, we're going to be left with, he says, looking at his notes desperately, because he's thinking, what have I done wrong there? Oh, I've written it wrong, haven't I? That's x cubed, not 2x cubed. That's what I was thinking. That did not seem right. Did not seem right at all, because I wrote it down wrong. Idiot. Right. So, let's do that again. So the 3x to the power of 4 plus x cubed minus 2x squared. Right, I've now written it down right, okay? I will literally back and track. Sorry, that's confusing. I've just written that in there. And let's just rethink that bit. Okay, let's do that again. So, we are going to do... did we do what was left over? Yes. So 3x to the power of 4. Take away 3x to the power of 4 is nothing. 4x cubed, take away x cubed leaves 3x cubed. Blimey. And then minus 16x squared plus the 2x squared, because we're taking away a negative, is negative 14x squared. Confusion averted, hopefully. We then bring down the next bit, which is negative 7x. Okay, let's try that again. And let's go for the red. 3x cubed divided by 3x squared. The 3's will cancel out, and all we're left with is 1x. So we put an x there. Let's put the x over here, and then let's expand again with 3. Oh, sorry, what am I doing? Yeah, 3x squared plus x minus 2. Right, there's my original expression. We times it by the x. Sorry, I'm sort of confusing myself now. If we expand the bracket, we have 3x cubed plus x squared minus 2x. And we rewrite that over here. 3x cubed plus x squared minus 2x. Remember, keep all of the bits of your polynomial lined up. And we take one away. 3x cubed, take away 3x cubed is nothing. Minus 14x squared, take away x squared makes minus 15x squared. And then negative 7x, take away the negative 2, means we're adding 2. So it's negative 5x. And bring down the 10, or the plus 10 on the end. And we do it all over again. God, I hope this is the last question. Minus 15x squared divided by 3x squared. Well, the 15 divided by the 3, or rather negative 15 divided by 3, leaves negative 5. X squared divided by x squared is nothing. It is naught. So we're now left with the minus 5. Let's bring over our cool, groovy factor over on the side. So 3x squared plus x minus 2. Once again, same thing again. Times it by the 5. We get minus 15x squared minus 5x and plus 10. Yay! We've got our expression. Thank goodness for that. Plus 10. And when we take one away from the other, we are left with nothing. So, if we're going to solve it... Goodness me, I've sort of run out of so much space here. I'm going to have to go to a different colour just so it stands out. Right. So, our factors are x plus 1, 3x minus 2. Those are my two original factors. And I've got x squared plus x minus 5. Now, that isn't going to factorise, is it? Which is deeply annoying. Which means we need to use the quadratic formula to solve the last bit. But your values of x are going to be x equals negative 1, x equals 2 over 3, And then you're going to use the quadratic formula on here. I'm not going to do it now because it will just take an awful lot of time. You know the quadratic formula, minus b, plus or minus the square root of b squared, minus 4ac all over 2a, etc. When you do that, you get two answers. And if you put them in surd form, they are minus 1 plus or minus the square root of 21 over 2. That's just in surd form. All right, that gives you, there are 4 solutions to that particular polynomial. And we'd expect 4 because, you know, it's got x to the power of 4, so it's likely to have 4. Okay, I know it seems like a big thing, all right? But honestly, once you get into the swing of it, just try some easier ones. This is by far the hardest sort of thing you're going to have to do here, like as far as this is concerned. It's unlikely to be like this. But it's still the same process. Practice the easier ones first is the thing. So those are the questions you need to do. Page 95. If you're working in this book, The Further Mathematics, I am not sponsored by them. Please sponsor me. Sponsor me if you own this book. I'm not sponsored by them in any sense of any form. Anyway, I need to go and lay down now and think about Christmas. Bye-bye.